Ryan, we're having an argument about your existence.
He doesn't exist.
So hopefully I remember to email this video to you. But we're going to do more triangle work today. So our homework is 19 to 24. Again, just to reiterate. So I want you guys to take a little bit of time, work with your partner or your team or those of you who would like to just ignore me, I guess work independently. But we want to try to solve these 9 triangles in the easiest way possible, trying to remember rules or tricks or methods that can easily lead us to our solution. Then we'll discuss what interesting things we see, how we think they could relate to each other, what rules we might be able to create moving forward. So take about 10 minutes probably. Maybe even longer, maybe even 15. But I'm really just going to sit over here and hang out while you guys do this. If you have small questions, I guess throw them at me, but I may or may not answer because we're going to discuss all these together. So if you get stuck, maybe skip it, come back to it, because another problem might jog the memory of what you need for this. If we quickly remember some rules just from yesterday, just to get them down. We'll start with the easy one, at least in my opinion. In a 45, 45, 90, I'm not even going to write the 90 because we assume we're working with right triangles here. How do we solve for my hypotenuse or for my leg? Like, it will really solve either way. Chris?
The 2 legs are the same, so you just multiply the leg length by square root.
Yeah, so rad 2 times leg. Or if I reverse this, to solve for leg, it's just hypotenuse divided by rad 2. Right? Because we're good with algebra. We are pretty slick working with those. So in a 30-60, if we say the short leg is A, what else do we know? Okay, so hypotenuse is double short leg.
Use an exact form.
Yeah, like rad form, yeah. And long leg is what? What rad do we use here? Rad 3 times that short leg. Alright, dive into those. See what other interesting things you come across. And Ryan, I'm going to pause the video because we're going to just be working for like 10 minutes. It is a continuously rotate. If we have time at the end of class, I'll show it to you guys. But I'm very interested in engineering.
How do you get out of it? Like, does it just go around?
You go in from the side, and then you start like you of course are going down. You're constantly falling, but as it rotates, you're going through different parts of the slide.
Whoa!
Yeah, and then it shoots you out the other side. So you come in one side, you ride it. And then but really, riding it, you're just going through the tubes as it spins the tubes around you.
That sounds so much fun.
Shoot you onto the concrete again?
No, it's shooting you into another water slide. I'll show it to you guys. Do we have the same thing for A? Or are there any that we should discuss? Any interesting ones here?
I mean, there's
a lot of
Pythagorean triples that were
Pythagorean
interesting. 3, 4, 5.
So I hear a lot of people saying 3, 4, 5, and did while you were solving.
And 3,000, 4,000, 5,000.
Because then this hypotenuse is
8, 10, 6.
this hypotenuse is
5, 13.
ooh 13. Well, that doesn't seem like a 3, 4, 5. Then.
Well,
Yeah, because it's not
yeah.
3, 4, 5.
It is fun, but that is
And
I was 40.
Oh, I did that. So I did it with the F. Because if you multiply 12 times 3 and 5 times 3 to 15, so you multiply 13.
So this is a dilation from F.
Well, so is G.
And G, well, yeah, so is G. But easier to see that it was a dilation of C. Because, wait. Back
It's
up.
a dilation of C.
You
That's what I meant.
said,
That's what I
so
meant.
H is a dilation of F. G is a dilation of C or D.
Yeah.
Yeah, be careful. We have 2 different triangles we're working with. I don't like how some of these you can't quite tell the angle size because they just kind of throw a triangle up there and then they label the sides and they say the angle size doesn't matter because we're labeling the sides. But the dangerous thing here is this angle's fairly acute. More so than this angle or this angle here. So these are 2 very different triangles. the 3, 4, 5 versus the 5, 12, 13, both are Pythagorean triples. Both are integer value base size triangles that can be dilated to create other Pythagorean right triangles with all integers, or not integers if we dilate by a scale factor that is not an integer. So 2 different types of Pythagorean triple triangles that I think you already figured out because you looked forward in your book. Or you just already knew the 3, 4, 5. But I don't know if we've ever covered 5, 12, 13.
Nope.
I
So-
figured out something with the 5, 12, 13.
Mhm.
The dilate, if you figure out how much has been dilated, like the multiplier of it, you can figure out the difference between the integers between the long side and the hypotenuse.
Yeah.
Like H and
Wait, how many triples are there?
Anytime we find integer that make a right triangle.
But how many are up there? 2 or 3.
Well, we have the 3, 4, 5,
Yeah.
right, which dilates to D and G. We have the 5, 12, 13, which dilates to H, and we have yet to solve I.
I is 40.
How do you figure I? So it's not a Pythagorean triple?
No, it is.
Oh, what is this then?
40.
40? So is that a dilation of C or F? So we find another one that is 9, 40, 41. And this angle would be really acute. More acute than this and more acute than that one. So this is why I don't always love how things look in the book, because you can't always like draw to scale like it should be. So we have 3 different Pythagorean triples up here. In case, because we come from different places, Pythagorean triple is just any time you have integer legs or integer sides that make a right triangle. So there are actually many, many more as we get bigger and weird. Like the 9, 40, 41 is relatively as far as we need you to know for things that we're going to dilate, but there are more options out there. You get bigger and bigger triangles to get there, though. So we now are recognizing Pythagorean triples, right? So Carl noticed some patterns. He was determining side lengths, and we already talked about these. So I bet we could figure out why they're called Pythagorean triples, because we already know that from Math 1, difference between CPM and Pearson. Can you find any other ones? So we know 3, 4, 5. Like, can you? I mean,
Not off the top of my head, but I'm sure there are. I'm 100% sure there are.
maybe. I don't know, but it's got other triangles that are supposedly right.
Yeah, do more.
Check out this one. It's not. It's hard. We're just practicing our skills to make sure we've got it down.
This
pat.
entire thing is solving the triangle.
What will the short leg on A be?
6.5.
6.5, right? Half your hypotenuse.
That's an ugly. You're
Or root 3 times 6.5, either way. 18 and 24. Is it a dilation of any of our Pythagorean triples?
3, 4, 5.
It's a 6 times of the 3, 4, 5. So my hypotenuse would be?
30.
C is what kind of right triangle?
I haven't even started C.
I'm making
I
my work
haven't- I'm
nice
just
that I
not-
can
Well, then
recognize
it's
3, 4,
also
5
it's the 45-45.
dilation.
So it makes it what kind of triangle? That's why it's special, but what kind of triangle? Isosceles, right? So it's isosceles right triangle.
Possibly.
We'll do some randomness here. Jenny, how do I find the long leg in D?
Multiply it by, wait, okay. 7
Yeah, 7 radical 3. And the hypotenuse there is just 14. Oh, and what about in E? Does that seem to be a dilation of any of our triples? You could have dilated from the 4, right? And then it would be times what? If we go from 4, so it'd be times 5, right? Would that hold true 5 times? No, so that doesn't work.
I don't think it works with any of ours, no.
5, 12, 13?
Yeah,
Four.
So that'd be a
4
4 times dilation.
So it's
Is-
48.
So this is a 4 times, and I don't like using x for times, but this is 4 times our which triangle? 5, 12, 13. Get that in your head. 5, 12, 13. So this long leg is the dilation from the 12, 48. How does the hypotenuse in an isosceles right relate to the legs? Yeah, times radical 2, right? So to get back to the leg, it'd be...
Radical 18. Wait, no, because it would be radical 13. I mean 36 to one leg. Radical 2.
So we're going to have 6 divide by radical 2, right? And if we want to put both of them into radical form, which then can be looked at as 1. We wanted to show the process how to get there. So then, Chris is saying it becomes radical 18. Is there another way? But is there another way I can write that?
Yeah, you can just
Three.
right here.
3 radical 2.
Nice. Yeah, 3 radical 2 would be a cleaner, well, it depends on how you think about it. But we like to factor as much out of the radical as possible. So getting down to a radical 2 or a radical 3 or a radical 5 is nice, if we're able to. Alright, so we still haven't found any new Pythagorean triples then from this work. Right now we still have more investigation to do. So now we get algebraic with our triangles. So take a little bit of time. Check these out. If you get done with 15, move on to 16. Try to solve these using variables. Now solve with variable lengths. Yes, you can. Because it would still be like a dilation form. Because if x is going to stay the same, right, that x has to be the same as that x, so it is a dilation of the x is just your scale factor, essentially. But are you looking at E?
No, look at 16. Hey.
Oh.
How did one of those happen? I did. Oh.
What? Don't. What?
Weird.
We're gonna get there. You're just ahead. But since you're there, we might as well start talking about 15.
Oh,
So 15, I think we got x, x, and then how do we find the hypotenuse? Ethan, what do you got for the hypotenuse here?
You just multiply it by radical 2.
Yep. So radical 2 times x. However you do that. For B, what's my long leg? Gunnar, what do you got in B for long leg?
Y radical.
Y rad 2.
Rad 2. Rad 3.
Had you said? Okay.
Yeah.
Sorry, I thought you said 2. I was gonna sit on that until somebody said something. Yeah, 30 degrees, rad 3. Do not actually use the wrong one. Hypotenuse. Easier than a long leg.
Oh, you're asking me again?
Sure.
Okay. 2y.
Yeah. What about C? 5x, because x there is actually just our scale factor, getting us from 3, 4, 5. D, Ethan. Sorry, now your card's actually up.
The hypotenuse, it's like the same thing as C, it's just a different triplet, so 13x.
Just the other Pythagorean triple. And then Ava, what about E?
E would be
Short leg?
the short leg is x over 2, and then the long leg is x over 2.
Questions? You all good? Sweet. So, if we add a line here, what we already started talking about, what kind of triangle did we then form?
Isosceles.
Yes,
No.
kind of. Equilateral. But an equilateral is isosceles, right? So, yeah, that's why I said yes, kind of. Isosceles, but it's also actually equilateral. And we know that because the base of this house-looking structure is equal to the sides, even though it doesn't look like it. So then, if we need to calculate area and perimeter, and we know that this is actually 6 inches. Well, okay, perimeter we can do pretty easily on there, right? If one edge is 6 inches, what about area?
Oh, area, you split it in half on the top.
And then it would just be 3.
Yeah, then you have 2, 30.
Well, then you have the hypotenuse, and then you could do like a.
Yeah.
Basically, the height of the triangle.
So you saying split it in half? We really just are looking for the height.
Yeah.
Right, so we don't actually need to split it. We need to drop in altitude. So it's like splitting. What do we know then? What about the short leg? What is now the short leg? It's 3, right? Because it was half of the 6. And then what kind of triangle do we have? A 30, 60, 90, because we break an equilateral and we make a special right. So our 30, 60, 90, and we now have the short leg, and the hypotenuse is double that, which, well, we already knew that. This is one of those properties. So what is the long leg, or the height?
3 radical 3.
Yes, thank you, Gunnar. So then we can solve for area using half of base times height for the triangle section, and just the 6 times the 6, plus for the rectangular section. Questions on solving for that one?
Wait, would that mean that at the end you would have 36 plus 9 radical 3?
So you'd have, yes, yep.
Right.
9 radical 3 plus 36. Dr. Smith always said, if you can't do anything else, just draw a line. He was my favorite math professor in college. Because he was awesome. We can talk more about him at some point. probably can just try to bring him up as we go through the year because he's fantastic. He's still at Otterway. So if you go to Otterway, go hang out with Dr. Smith. What can I solve when I draw the line breaking up this square and triangle? Colin? What can I solve now in B?
Well, you can solve the length, the size of the square, and you can basically solve the whole thing.
Yeah, because now this is equal. Like, we know that those are equal because now I put a point directly across it. We know the distance across it is the same as the distance across it. And because this is a 45-45, I now know that. So what is that length that connects it all? How do you know?
Because the hypotenuse of the triangle is 6 times rad over 2, and yeah.
Yes. Yep. Agreed.
I shouldn't have to explain that.
You shouldn't have to explain any of it. I'm just making sure you guys are like able to defend it. Because now the other thing to realize is rad 3 and rad 2, both of them are bigger than 1. So always think, which is bigger? Am I getting bigger or getting smaller? In the past, when I've seen people have mistakes with this, that's helped them like, oh, my leg has to be smaller than the hypotenuse. Because if this was a constant, it might not be so obvious to divide by radical 2. If it was just like an integer. So if you think about my leg must be smaller, I have to divide by the radical 2 as opposed to multiplying. That can help kind of straighten things out. And here, I guess my drop would be there. What does that do for me? Donner?
You know the area of the rectangle, and then the sideline is the short side, and it's just a 3, 4, 5.
Ah, so this is 3. How do we know that this is 4?
Because the other 2 are 3 and 5.
Okay.
16 plus
That's
9
the right
is 5.
So it has to, there's no other way?
That's the easiest for me.
No, I mean, there's no other option for the leg, like it has to be 4.
No.
You're right, I'm just making sure that you guys have thought this through. If the hypotenuse is 5, and if one leg is 3, there's no other option aside from this being 4. Now, the dangerous thing, what I've seen on like an SAT or an ACT, is they will tell you, given a right triangle with sides measuring 5 and 3, what are possible lengths for the third side? It's not just 4. Because if they only tell you sides of 5 and 3, you also have to think about the situation where you have 5, 3, and a hypotenuse actually bigger than 5. So be careful. When we know the 5 is the hypotenuse, we're good, it's easy. Right? I tried. So be careful with phrasing. SAT and ACT kind of, is anyone taking the pre-SAT this year? Yeah. So on there, look at those problems really critically. They love to throw those little like, oh, you think it's a 3, 4, 5, and it might be, but it might not be. And I think we all have the skills that we could calculate area and perimeter for all of this. You have about 5 minutes. You can go ahead and start on your homework for this year.
Wow, I used up an entire page plus this. Of course, I used a lot of this. I used like at least 2